shape, outlier, center, spread. Shape, outlier, center, spread. So this is the front of our note today. Shape, outlier, center, spread. I would put it so that it opens like a book. And SOCS, S-O-C-S, is a way to analyze descriptive statistics. SOCS is a way to analyze descriptive statistics. So when you're looking at a graph on the math test, when you're looking at a graph on the state assessment, when you're looking at a graph on your homework, the acronym SOCS, S-O-C-S, shape, outlier, center, spread, those are the 4 items that you look for to analyze your graph. Is it a good graph? Well, let's look at the shape. What does the shape tell me? Let's look, are there any outliers? What does that tell me about the graph? Where's the center of the graph? Is it truly in the center? And spread, is the graph spread out or is the spread small? Those are the 4 areas of graphs that we look for. So open it up. We're working in quadrant, right? If this is the graph, coordinate plane, 1, 2, 3, 4. We're in quadrant 2, which is just the top left corner. And we're going to talk about shape first. So again, those of you that are confused on where we're located, turn around and look at me so you can see the whole thing. Here's my book, right? I open it, and I'm in the top right corner. Okay, shape describes what? What do you think shape describes? Yeah, how it looks. It describes the distribution
I think I might have got mine wrong.
of data.
They need to do what?
Shape describes the distribution of data. How it looks. What does it look like? There are 3 things we look at when we talk about the shape of data. The first thing we look at is something called symmetry. Is it symmetrical? Yes or no?
And then it's like that.
Tell me about symmetry. What does it mean? Who said what? Cameron, what'd you say? Yeah, it's equal on both sides. Like, remember elementary school? Elementary school, like the capital letter A is symmetrical because you can fold it in half and it lines up perfectly. Remember those shapes you used to make where you painted one side of the paper, folded it in half, opened it up, and it always made a butterfly, I feel like? Symmetry. Is it a symmetrical graph? Can you look at something and tell me about its symmetry? Yeah, you can say yes, it's a symmetrical graph, or you can say no, it's not symmetrical. The right side's bigger than the left side. You look at symmetry. Sometimes you can look at the number of peaks. And you can make an inference from that. So like here's a graph. It doesn't have to be perfect. But what can you tell me about the number of peaks in this graph? Don't overthink it. Zach, what? There's 2 peaks. Now that's a very surface area and surface level answer. If there are 2 peaks, that means this number happened more than this number, right? So this number and this number happened the same. So if there are 2 peaks, what could you say? There were 2 what? What number happens a lot? What's it called?
2 modes.
Yeah, you can say that there are 2 modes. Those are modes. You could say it's bimodal. If there are 3 peaks, what could you say? That there were 3 modes.
Trimodal.
Right. So the number of peaks helps you talk about the shape of a graph, makes you have some inferences.
Yeah, if you have 4 modes, I call that quadmodal.
And last one we talk about, which is a little hard sometimes to wrap our heads around, is called skew. Have you ever heard that before? Zach, what does it mean?
It means if the distribution isn't fairly equal on both sides.
Yeah, if something's skewed, it means this one side happened more than the other. If it's skewed, it means it's not even. So there are a few ways of looking at skew. There's what's called a left skew, and there's a right skew. And skew can happen, or symmetry, or number of peaks. Those can all happen in any type of graph that we've made so far. Let's make a quick number line. We don't need numbers on it, but we can just talk about a dot plot. So if I had I'm just making stuff up. It doesn't have to be perfect. Something that looks similar to that. Doesn't have to be exactly mine. But here's a dot plot. And using the 3 things that we look at for shape, can we analyze this dot plot? Is it symmetrical? No, it's not symmetrical. If I folded it in half, it would not line up. So you'd say, no, it's not symmetrical. There's more data on the left side. Number of peaks. Well, it's kind of hard to tell. So sometimes if you can't really see it, you can sketch in kind of an arch to help you. Or, you know, how many peaks are there? I'd say there's about one peak. So there's only one mode. Now we're going to talk about skew. And here's how you look at skew. If you draw one curve, this is called a bell-shaped curve. If you draw a curve on top of it, there's missing data. Right? This part of the curve is empty. This would be a right skew.
Well, skew basically means non-symmetrical. It's the opposite. That's what I'm
The right side of this data is skewed. It's missing data on the right side. It's right skew. If you forget how to do this and you go home and look it up on the internet, right skew is also known as sometimes positive skew.
So left is known as negative.
Correct. So that would mean that left is a negative skew. It's about 50-50 on what website you find, if it's going to be positive or negative or left or right. It also works for histograms.
And that looks like a histogram to me.
If we're looking at this histogram and we're only analyzing the shape of this histogram, is it symmetrical?
No.
No, it's not symmetrical. There's more data on the right side. Number of peaks. So if I'm looking, you know, maybe you could say there's one there, but it's not necessarily a peak. Maybe just one peak. So the mode happens here. And if I'm looking at the skew,
I believe it is a right skew.
it's missing data over here. So this is a left skew. You can also analyze with box and whiskers. Looking at this, is it symmetrical? No, but it's kind of close. I mean, maybe you could talk about how the boxes in the middle of the box plot are symmetrical, but your two outer parts are not symmetrical. Number of peaks you can't identify in a box and whiskers. Skew, let's extend this a little bit over here. If I made this side longer, I would say my skew is here, so this would be a what skew? This would be a left skew also. So you can talk about the shape of all three types of graphs we've made. Shape is pretty easy. Outliers next. What do you need?
So basically, skew is basically the opposite of symmetry.
Correct. Skew is the opposite of symmetry. If it's heavy on the right side, it's skewed on the left.
Yeah, and outliers are basically smaller or larger than they have any right.
Let her stick to this, okay?
Data values, so we're on to outliers, and outliers are data values that are greatly different from the other data values? Now, the middle school level of understanding of an outlier is pretty basic. It's just this. Is it greatly different from the other data values? Can you easily identify? So if I give you this data set, 3, 5, 7, 9, 30, 11, 2, and 4. Our middle school definition is a data value that is greatly different from the other data values. And if the data is 3, 5, 7, 9, 30, 11, 20, and 4. Looking at this, can you, just by looking, identify the outlier? Quentin? 30. Because it's greatly different. We've got one other double digit, but it's only 11. And then we've got 30. So most of them are single digit numbers. We've got one double digit, but it's 11, so it's not that great of a number. 30 is the outlier. Now you may think that's super easy. Try example 2. 15, 17, 18, 19, 14, 20, and 7. Is there an outlier here? Is there an outlier here? Camden. 7. 7, I agree. It looks like it's an outlier.
Yeah.
Here's my challenge to you. This is statistical. This is not middle school statistical. This is outside of middle school statistical. There's a formula for outliers. The outlier formula is as follows. The IQR times 1.5. Then plus or minus the quartiles. What does IQR stand for? Do you remember that? Tommy? Good. The inner quartile range. Times 1.5 plus or minus the quartiles. So let's see, is 7 really our outlier? So first I have to put them in order. 7, 14, 15, 17, 18, 19, 20. Did I get them? 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes. Okay, so my median is 17. So that means 14 is my lower quartile and 19 is my upper quartile. So what's my inner quartile range? Zach? 5. I would do 19 minus 14 to get 5. Now I'm going to do 5 times 1.5. To get 7.5. And then I plus or minus that to my inner quartile range, or to my quartile. So I'm going to take my lower quartile, 14 minus 7.5. So anything below 6.5 is considered an outlier. And I'm going to add it to my upper quartile. Oops, that was multiplying. And anything above 26.5 is considered an outlier. So is 7 really an outlier? No. It's not technically, mathematically speaking, an outlier. It has to be 1.5 the interquartile range. Zach?
You were saying like the middle school they would consider it. Does that mean like on our state assessments and whatnot it's gonna be
It won't ask you that. It'll be obvious. It'll be like this.
Okay.
Jacob?
I like to think of outliers as they're greater, if they're much greater or smaller than they have any right to be.
Yep, they're way too big or way too small compared to everything else. Center. This is a pretty easy one. If you're analyzing the center of your graph, where are you looking?
Middle.
Yeah. What's the word for middle?
Center.
Median.
Fail.
The middle or the median of the graph. Now you may say, this is dumb. The middle's the middle. But maybe it's not. Maybe it is. Let's make 3 graphs and let's talk about them. What can you tell me about the middle of this graph? Is the middle of the graph in the middle? Yeah, here's the median.
Not during class. I do.
Is it really in the middle?
I do it during my class. Not now.
Yeah, it's really in the middle. So you would say that the middle, the median, actually is in the middle of this graph. This is a true center of the graph. If I had a histogram, right, if I'm looking, the middle's probably about right here. Is that really the middle of your graph? No, it's probably not really the middle of your graph, but is it close to the middle of your graph? Yeah, it's pretty close to the middle of your graph. So you can describe that. Dot plots and histograms tend to have their median actually be in the middle. The one that does not is box and whiskers. A box and whiskers graph can look like this. Where's the median or the middle of this graph? How do you describe where to find what physical part represents the middle or the median of this graph? Camden? Yeah, the middle line. Here's the median. Is that in the middle of the graph? No, that's not close to the middle of the graph. So you could describe the middle of the graph here. You could talk about the middle. The median is not in the middle of the graph. What does that tell you? It tells you that half the data is right here. And the other half of the data is really spread out.
Yeah, there's probably an outlier there.
Probably is an outlier. That tends to what makes it look like that.
Yeah.
And the last one is spread. And spread describes how wide the graph is. So, if I have a box and whiskers, and it's from 0 to 100, that's a pretty big spread. My data goes from 0 to 100. If I have a histogram that goes from 2 to 6, 7, 2, 3 to 11, 12 to 16, 17 to 21. That's not a very big spread. What's another word for spread? Huh? Who said it? What is it? Range. This is really the range of our data. So you can look at your graph and you can use SOCS to identify it all. You can use the shape of the graph. You can describe the shape. You can look to see if there's an outlier. You can look to see about the center. Does the center truly match up? And you can talk about the spread. All right, last but not least, you're going to take these notes, and inside your notebook, on page 7, you're going to glue them down.